Back everybody to the Predictive Analytics World Climate stream. I hope you all enjoyed the networking session before the lunch break, and then I of course hope you enjoyed the lunch. Welcome back to the afternoon session, and we will right now dive into the next expert round. This time it's going about space data, and we are very happy to have Nicolaus Hanowski here with us, who will start this expert round with his contribution. Nicolaus, you started as a researcher in the US, and then you worked for the mission operations in the German Space Operations Center as well. You became about a bit more than a decade ago, you became responsible for the development of science crowd segments to missions with names that many of us might be familiar with, like Rosetta mission, Solar Orbiter, or Euclid, and so on. Then since 2014, you are responsible for operations and ground segments at the European Space Agency. And we are very happy to have you here. Looking forward to your contribution. The floor is yours.
Okay, so good afternoon, everyone. It's after 12, so I say good afternoon. Thanks a lot. I'll try to share my screen to go directly into the presentation. Just a second. And now you should be able to see the slides. Can you see the slides? Hello, can you hear? Can you see the slides?
Yes, we see the slides. Yes. Perfect.
Okay, very good. Okay, good. So I will use my 10 minutes to give you an initial overview of what we do in Earth observation in terms of data generation, data management, and data access. The first thing that I want to show is a little bit the infrastructure that we have in space and that we can use in order to generate Earth observation data. The reality is that in Europe, we are in charge actually of the largest space infrastructure for Earth observation. And there are different components that make this infrastructure that combine into the largest fleet of satellites to generate data that can then be used to generate information and data products. What you see here is an overview of the ESA program, which has a science component, a Copernicus operational component, and a meteorology component. So these are all Earth observation satellites for specific purposes. In science, we're trying to build and operate satellites that try out new instrumentation, new types of measurements. In the Copernicus world, we are operationalizing established Earth observation techniques, such as optical data, such as radar data, specific atmospheric measurements, for example, and so on. And in meteorology, we have different sensors in order to determine the components in the Earth's weather systems and climate relevant parameters. So these are the three big elements, and you can see there's a huge number of satellites that is either flying or that is in preparation. And when we talk about European assets for Earth observation, we should also keep in mind that this is not only the European Space Agency, but there's also national missions. There are German missions, French missions, Italian missions. We have commercial companies in Europe which are also contributing to the missions. And we have airborne data. We have airplanes that are supplying data for Earth observation purposes, and of course in situ data measurements on the ground, which is complementing all these data sets. So all in all, the European landscape in Earth observation is constituting the most sophisticated Earth observation space infrastructure in the world. Is particularly interesting because usually in space activities, the US is much more advanced than Europe. And here we have a case where Europe is actually leading. And one indicator of the quality is that the budget for Earth observation in Europe is a bit larger than the budget for Earth observation in US. When we look at the national agencies, the European Space Agency has a bit more money available each year to spend on this infrastructure and on the data management for Earth observation than NASA has, for example. So that's the basis on which we built the data generation. And when we talk about data management in the space operations context, in the Earth observation context, we have to realize that this is a long list of different tasks that we have to fulfill. We need to plan the instruments on board of the satellites so that they switch on and switch off when they're supposed to. We need to calibrate the instruments. We need to make sure that the data that is being generated is well structured and organized in the data streams to the ground, because we have only a very short time when the satellite passes over our ground station to actually acquire the data from the satellite. So all of this needs to be very efficient. Data acquisition, so with the antennas, we are retrieving the data from the satellites. Data dissemination, various networks on the ground make sure that the data are disseminated to the various processing centers. And then the data is being processed, transformed into information products of different levels, and then put into the various archives. For example, retrieved from the archives for reprocessing. So the architectures that we need to use for archiving need to be feasible to do these things. We need to provide data access. So that's the key topic that we are discussing now. We want to make sure that everybody can access the data. And we use data-based modeling in which we use high-performance computing, for example, to generate models of specific changes on the Earth that we want to understand and want to predict. Data user curation, we want to understand what the user really wants from the Earth observation data. We need to check the quality and the integrity of the data, and we need to make sure that the data flow is secure and stable. Here are a few elements of the data access, and I think in the discussion round we will definitely focus on the data access options and how to improve these. The key message here is that all data from the European Space Agency and much of the data of the national mission is free and open. So in principle, it's only a matter of comfort and easiness and versatility of the data access points for you to get the access. There are no legal implications that should be contrary to any of the ideas that you have in terms of using or managing the data yourself. Data access facilitation is encouraged, supported, so we are constantly looking for entities or individuals who want to facilitate the data access. We want to make sure that the number of users and the traffic of this data is increasing. So the ultimate element of success on our side is to make sure that the data is flowing free and open.
I think we lost him. Christian, you're muted.
Thank you as well. Okay, I think we lost Nicolaus.
No, still mute.
I guess we shall wait.
So I think we lost Nicolaus. Maybe his internet connection broke.
Yeah, it looks like a bit more a technical issue.
And we don't hear you very well, Christian. Could you level up?
Yeah. Sorry about that. Is it better?
Yeah.
Thank you. Technicalities. To our understanding, Nicolaus has technical problems, so I think it might take a bit longer time until he is back. I would ask Niklas in the meantime to prepare. Let's wait maybe half a minute or so if Nicolaus comes back. If not, then we will jump over to Niklas and give Nicolaus the chance later on.
Yeah, I'm sorry for that, dear participants. Yeah, that's the thing with internet connections. I don't know where Nicolaus is located at the moment, and maybe there is unstable internet connection. So
no, we should make a Slido questionnaire now, letting the audience vote how many of you have faced such difficulties before. I would guess the quota is up to 98, 99%. So
yeah,
this is.
But as said before, with Space Link coming, you might have a backup, but you might have a latency delay in the connection. Yeah. Okay, I don't think he's coming back.
Too soon, huh? Yeah. I think, Niklas, if you might come to stage, we continue with you. And if Nicolaus is coming back, then we definitely have him in the end.
Okay, I will start my presentation. Give me a second. Now you should see my slides, right?
Yes, we see your slide exactly. And let me just introduce you a little bit. As I learned, you are a student at Open University in London. I know that facility, so that's great. You are a software developer by training, and you are the founder and the initiator of the project you want to talk about, which is openspacedata.org. So very much in line with the space data and of Copernicus and others that Nicolaus was telling about. Looking forward to what you and your organization are doing.
Yeah, thank you very much. I think the most important quote of the last talk was the data is free and openly flowing. That is a very important quote, and I think the most important slide we've seen in this panel. So now officially, hello space people, thanks for having me and that you are joining my talk today. And for the opportunity to tell something about why Earth observation data are the coolest data ever, how they can help us with the big problems of our time, and the mission from my heart, why everyone should be able to use them. So some words about me. I'm Niklas. For the last 12 years, I've worked in various projects, mostly as a software developer or product manager, helping to develop easy-to-use software and apps. Out of pure interest, I started studying geoscience again a few years ago alongside my job. I fulfilled a childhood dream, so to speak. The combination of technology and science opens up great opportunities. So besides open space data, I also founded the Disaster Tech community, a global open source community and think tank consisting of developers, designers, civil engineers, scientists, that develops tools and resources to help people in crisis situations. So let's go. Like I said, Earth observation data can help us tackle the big global and local problems of our time. So what are the biggest problems of our time? According to the World Economic Forum's Global Risk Report for 2021, they are the ones you see on the slide here. The list include, for example, major geophysical hazards or national resource crisis, but also economic or social risks like the debt crisis or the erosion of social cohesion. Not all of these risks are unavoidable, of course, but they do pose a risk of changing our lives in a negative way. Why I'm telling you this? Earth observation data or satellite data in general offer an enormous treasure trove of information. These data can help us to better assess existing risks, identify impacts, and develop measures to mitigate the risks. Earth observation data can help actively with almost half of the risk presented here. For example, to analyze the consumption of natural resources, to recognize the damage after terrorist attacks, or to plan infrastructure so that is less vulnerable to disruption. The risks here highlighted in red or in yellow are only those in which Earth observation data are already being actively used. For the other risks too, these data can help us make better decisions. But to be more specific, I have brought some examples of what we can see on satellite data. So imagine, what is the most beautiful place in the world in your eyes? A place you've always wanted to travel to, but perhaps couldn't afford it yet? No problem with the data of the European Space Agency or other public space agency, or also commercial agency like Mr. Hanowski said. We can discover the entire beauty of the Earth from a bird's view and from the couch. For example, here you can see Sharm el-Sheikh. It's one of the most expensive seaside resorts in Egypt. But the use of the data is not limited to nice landscape from a lofty height. We can participate in global events in near real time. For example, when a ship blocks the probably most important trade waterway in the world. All of you saw it, hopefully. And we can examine the extent of this economic disaster. As you can see on the right, each of the bright points, of the bright dots in the middle of the picture is a ship waiting to continue its journey to the Gulf of Suez. By the way, in this picture, there are 130 ships waiting for continuing. Or 2020 was a record year for wildfire in the Russian Arctic. For months, Siberia suffered from an extreme heat wave. In June last year, the temperature even rose to 38 degrees Celsius. The result, large-scale bushfires. Like this one, you can see 360 kilometers long. But Earth observation data contain much more information below the spectrum of colors we know, or we can see. We can combine different bands and calculate with them. In this way, we can highlight curtain information and look beneath the surface, so to speak. Here is an example. Different bands were combined to visualize the moisture contained in plants on agriculture land. Crazy, right? But we can also monitor long-term changes in the environment, like the Forgensee in Bavaria, Germany's largest reservoir. In summer 2017, you can see on the left, and in the summer 2018, you can see on the right, nothing more than a puddle can be seen. The last two examples show that the immediate effects of the climate crisis can be seen more than clearly with the eyes of a satellite, even from a distance of 400 kilometers, comprehensible and transparent for everyone. In this way, we can make it much clearer to people what is at stake here. Not about emotionless numbers or gray statistics, but about the fact that this crisis is already happening. And not on the other side of the world, it is happening right here, on our own doorstep. And the best part is, me and you bring everything we need to do it to fix this. We know how to interpret data correctly, have a deep technological understanding. Many of us can code. There are almost no limits for us to what we can do with Earth observation data. We can analyze any place on the Earth in a matter of seconds, and we can develop scripts that do the work for us. That is great. And there are a lot of software that are helped and that are perfectly tailored to us. For example, the Sci-Hub from the European Space Agency, where you can access the data directly from the ESA. Or the Sentinel Hub, the EO browser from Synergize, or even Google's Earth Engine. I use each of these tools almost daily, depending on what I have in mind. However, this is only a selection. There's a wide range of tools, each with their own strengths and weaknesses. But the only problem is you are privileged. Don't get me wrong. I think it's great what we can do with technology today, and that basically anyone can code, literally has the world at their feet. But we are not the rule. In terms of the world population, on the scale of the world population, we are just an exception. By the way, there's one global risk that I failed to mention earlier, the growing digital inequality, because that is precisely what is growing in the EO field. New tools are emerging all the time that make it easier and easier for us to use the data. and handle the data, process the data, but very few of them consistently address the needs of the general population. To people who can't code, who can't handle data, or who don't speak technical or scientific language. Just ask your friends or family, who of them knows what GIS means, or what satellite bands are, or how to manipulate raster data. Most tools simply do not speak the language of people who do not have the privilege of being at home in the technical world. There are various challenges to overcome for them. The topic is very complex for itself. When it comes to the electromagnetic spectrum, most people have probably switched off in the physics lesson, right? But do you need this knowledge to be able to use the data? Don't forget that this is not about precise scientific studies. I'm talking about giving everyone access to it. You don't speak English, you are not familiar with technical terms, then you already have another problem here. You have to be able to download and process the data. And finally, you have to be able to interpret the data correctly. You have to get from data to information, from abstract to the picture. That's a lot of barriers, right? I think data should not only be accessible, but also usable for everyone. This means that we also need to create interfaces that speak a simple language and that enables everyone to find the right data, process it, and recognize the information in this data. There are a lot of tools that making working with EO data much easier, but you always need a minimum of prior knowledge to get started. I say we need zero knowledge tools. I'm not talking about making existing professional tools more user-friendly. If we only do that, we always have to make a compromise between the ease of use for beginners and, on the other hand, the efficiency for professionals. I don't want a compromise when it comes to the equal use of open data. I'm talking about developing tools that are uncompromisingly and exclusively focused on first-time and non-professional users. Data is relevant to everyone. It should also be usable for everyone too. It should be so simple that students in school will be able to use it in lessons without any guidance. By the way, on the right side, you can take a look into the Snap Planet app by Jerome Gaspari, a great example of how Earth observation data can be accessible with the lowest possible barrier. It is also called the Instagram for satellite data. Zero knowledge tools, that is what we need. That's what I'm trying to do with Open Space Data. Open Space Data is a project that tries to make satellite data accessible and usable for everyone, regardless of prior knowledge, technical skills, or financial background. We do not want to assume any programming skills or prior knowledge of Earth observation. In other words, the interface does not overwhelm with technical terms, nor does it require complex inputs. A big difference from other tools besides prioritizing the audience to first-time users is that we want to empower the people. We focus on strongly education. This means that we provide users with the right data and also with step-by-step instructions to process the data. A key point of our strategy is that we offer the easiest possible access for first-time users and do not rely on users working with our solution permanently. And the best of all, the entire software will be free to use and the code will be open source. The whole thing is and remains an open source community project. Anyone can join it and contribute ideas. We are building a prototype right now, and anyone who wants to support this, you are most welcome. Thank you.
Thank you very much for this passionate plaidoyer about open space data. That's very nice. I can tell from my own experience, it's really a hassle to get grasp on good quality open space data, and working a lot with the Copernicus data sets, which is already a good thing. And so I think this projects like these are very, very interesting and needed. So thank you very much. We had, for all of you who have been present longer time, we had Nicolaus kind of being interrupted before. He still has some technical problems. We are in contact, giving him the chance to get back, but the technical problems persist. And then we have also problems, same wise technical problems with Thomas. He is also kind of willing but unable to currently go into the platform. Therefore, I would suggest that we are starting with the Q&A session already now, and then seeing if there is any more contribution from the other two participants possible. Then we use the rest of the time to give them also the chance to go there. So, as Martin wrote, please post your questions in the chat window, dear audience, and we will make it then here public and hand it over in that case to Niklas.
And Christian, you said you already has 1,001 questions, so maybe
1,001.
start with the first question.
Yeah, no, that is true. I mean, we are from our point of Sustainaccount calculating physical climate risks. We are a lot working with the Copernicus data, for instance, and we really saw the striking difference from the Copernicus data platform, which is very centralized, is ordered. You can find what you need. Towards, for instance, platforms of the NOAA and other American platforms, which are not so centralized and so on. How is there something you would suggest maybe to newcomers to that field if they want to get some orientation, what to do with space data, where to start with?
Yeah, of course. There are a lot of resources a newcomer can use. Also, the European Space Agency has a very, very good place you can start in the EO Academy. I think it's the name of it. And this are Moodles. So you can take online courses on radar data or on MCI data or whatever data you want. And you get a whole course on the theory to the practice and process your own data you can download in the Sci-Hub. But also the NASA have great education programs for people who want to get in this field. There are a lot of options, and there are also great webinars by Sentinel Hub, a tool, for example, where you don't need to any coding skills or just like that. You can start with a really simple interface, but you have to know some prior knowledge on the theory, what are bands are, what are different wavelengths, and which wavelengths I have to combine to get the results I want. But yeah, they have great webinars you can take in and get started in this field. I hope many of you will start after this panel. These are I just said, but it's okay to say it another one again. These are the best data to save our future and save or get against the risk I told before and handle them, and yeah.
Yeah. By the way, you already mentioned Sentinel Hub. What's the difference between Sentinel Hub and open space data? So,
yeah, open space data is, or in other words, the Sentinel Hub has target group or an audience of very professional people. So they have services like APIs and stuff like that. You can use their infrastructure to make your processions on the images. But the interface is for people like us very simple. But when I show this interface, a friend of mine or my mom, she will be complete overwhelmed because they are a language she doesn't speak. So that is the simplest description for it, because you have to choose which satellite you want or which mission you want to use, which bands you want to calculate with, and all this stuff. And for this you need some prior knowledge. And our track is to give people an interface they never heard on Earth observation, and give them an entry point with a language they speak. And we don't try to be the best tool for all people in the world. We just want to be the best tool for people they never heard of Earth observation.
Mm-hmm. So there's one question by Eric on the chat. Have you considered using augmented reality for ease of use?
Yeah, this is a really good question. No, I never used it for this, and until now I never considered this. But I think this could be a really, really great way to get people in this field. But the problem I have with augmented reality, when we comes to my mom again, she doesn't know how to start an augmented reality stuff. When she has any problems with her smartphone, she comes to me. So that's why the barrier maybe could be a bit higher than possible. But for example, for schools or for lessons in geography, this could be a really, really good tool.
And by the way, how many people are using your open space data? Sorry, Christian, just one last question.
Sorry, what was the question?
How many people are already using your open space data tool?
For now, we are in the prototyping phase. So we started on March and have a funding from the German Aerospace Center and the German Ministry for Education and Research to build the first prototype of this interface until August. So, and now we are completely in the prototyping stage. And for now, nobody uses it. But hopefully there are a lot of new people, they get into this field with our tool.
Maybe you need some beta testers from the audience.
Yeah, absolutely. Anyone who want to get into the project as a coder or as a tester or as a content creator or whatever, or just to have a talk about this topic, just get in touch with me. I'm very happy about.
I mean, I had an application in mind that could maybe fit in that sort of target group as well. I remember a few weeks ago, my wife, she's also a data scientist, and she works for a larger corporation, and they did a volunteering program at some point where they used space data from, what was it? I think it was just Google Maps satellite data, basically, to improve the mapping of villages, of smallholder farms, of small roads, and so in Central Africa, in an area where you would have no good data coverage on such points of interest and geolocation overall. And it was very nicely done. People without any sort of space data knowledge, as you pointed it out about wavelengths and so on. They were just kind of comparing what the satellite image shows to what the respective maps in the area, so OpenStreetMap at that time showed, and were able to kind of then annotate and draw things and so. And the case behind it is obviously disaster relief or any sort of protection of the local environment that does not have this data literacy, but also not the access to the technology that we do have. And so I could imagine that a lot of people would be kind of willing to learn how to deal with space data and simultaneously do something that creates an impact in the world.
Yeah, absolutely. That is a really good point. Most professional people are laughing about the Google Earth application, but Google Earth, the desktop application, I mean, because that has a bit more features, are a really good entry point for people to get an overview with satellite data from a specific area. You can have a specific timeline. You can go back in the years for 20 years or so, and can measure distances and all this stuff. The only thing you can't do with Google Earth is to combine different bands. You have just the true color view, so the colors you can see with your eyes. So, but this is a really good point. I think it is a good entry point for many people, also for the science. We are on the position we can code, and we don't use so simple tools like this, but because we could we need in the future some more skills on or some more features also, but for the most people, also scientists, Google Earth is absolutely have enough features to use it for their research. And another good service that need satellite data in disaster relief is also humanitarian OpenStreetMap. They use different kinds and different providers of satellite data to map regions with low coverage of OpenStreetMap data to help the International Red Cross also for the relief.
Yeah. One question, or one, maybe not a question, but more like a discussion topic. So I'm advising a lot of companies for their data strategy, and often when I'm telling them about open data or public data, I give an example, the open data by the European Space Agency. And often they don't know even about it, and they're very surprising. Wow, all the data is completely for free, and there's so much data that not only images, but also radar and laser data, and a lot of different kinds of data sources, but they don't know about it. And of course, I think 99% of all companies don't use for their business space data, but there's so huge opportunity. Do you have any ideas how to change that? And of course, the Open Space Data website could be one part of the solution, but what do you think is also necessary to raise the awareness for open space data?
Yeah, this is a difficult question because most ideas on how to use a technology comes with the knowledge about it and the knowledge what you can do with it. And when you know what you could do, then there comes a lot of ideas. Oh yeah, we can do with this with it and other stuff. There are very creative approaches on maybe infrastructure monitoring for pipelines also, where we can see with satellite data if there an spill in the pipeline or something like that. But we have to get the knowledge about this technology, and then the ideas come from itself. So I don't know what is a good approach to handle that in the media way. There are a lot of I see a lot of good stories in the last month. So a lot of stories with satellite data and interactive stories that use satellite data. So I think it's a slow process, but it's a process.
Christian, what's your idea on that? Do you have any? You're also working for corporates, not only for governments, but
yeah, it's a spectrum. You know, there are some corporates who are not in the space sector or image processing sector or something, but who nevertheless acknowledge that space data or space images predominantly can make a valuable business or at least lead to some kind of risk mitigation processes. So that is, for instance, if companies depend on natural resources a lot, then it's like food companies. They are using since kind of the last years, basically, also not only but also space data in order to identify harvests and try to kind of forecast also the harvests and try to hedge on that and so on. Where there were also some examples which made it to the press, but when you then dig deeper, didn't quite deliver on their promises in a sustainable way. Maybe the most promising or a prominent one that some have heard of is some company in the US that used satellite images to count the number of cars in front of, for instance, large supermarkets and stuff like that, in order to forecast or let's say have a real-time estimation of the revenues in that stores, and then use that as a forecast for earnings, meaning for the stock price. And I used to discuss this with some investment management companies or departments in some banks, and they tried this so-called alternative data for their own analytics inside the firms, but never went so far, never did succeed so much. So this is in finance or in investment management, it's always the question, can you find a tradable signal based on an information that does not that not everybody has in the world? Otherwise we would have efficient markets and it wouldn't be a tradable signal anymore. But it turns out that some things they have a temporal advantage in that area and some not. So
I mean, it's also the question whether there's alternative data, for example, for retail, GfK, Nielsen, they also collect data from the point of sale, and maybe if you have access to this data, maybe it's more expensive, but also it's more accurate. And this is, I think, also one problem of space data, that there are competing data sources for that. And I know also another case where they are monitoring or using satellite images to estimate the load of cargo ships, and then to
based on the waterline,
I think that's also one of the more famous examples.
And of oil storage tanks, the large round open roof storage tanks based on the shadow. This is all. It goes through the news, and then you read another article that some of the data was just collected by some guy running around in a jeep along the wells and just was photographing how it is looking like.
Yeah. Okay. So I don't think Thomas and Nicolaus are coming back. Nicolaus has still technical problems. But he informed us that he will give us his presentation, and we will put it on the Dropbox so everyone can download it afterwards. Unfortunately, I think he will also then be missing for the panel discussion in about 15 minutes. So for the audience, if you have any further questions, please use the chat to ask your question to especially Niklas, but I think also to Christian is also willing to answer your questions. I don't think I could contribute a lot of expert knowledge on this topic.
In the meantime, I would just ask you, Niklas, about a technical thing. What is currently the resolution, in visible spectrum? Let's say the resolution where you as a private person or private company would have access to.
It depends. It depends on the provider. So the European Space Agency, the Sentinel data have a resolution from 10 to 30 meters, or sometimes 60 meters. But we have also access to maybe ICE-Eye data. ICE-Eye is a radar data provider, so they have radar data, and they have the mission. I don't really know if they achieve it now, but they have the mission to have every hour, every centimeter of the Earth with radar data. So radar data is very cool besides the visual data, because you can look through clouds and stuff like that. So the weather things are not so important for radar stuff. But yeah, the other big companies like Planet Labs, they have 0.5 meters resolution for multispectral data, or the Landsat is, I think, 25 meters, I think. So in this range are the data we can get, and we can mostly get for free. When you are a research company, most of the data of the commercial providers you can get also for free, because the European Space Agency has a partnership with them, and you can apply for a research program, and then you get the whole data from mostly all commercial providers also for free.
I mean, this was also one of my questions I had watching Nicolaus and your presentation. So it's because ESA has so many satellites, the Copernicus initiative, and is there still a big potential for commercial satellite providers, or is in the near future all data is coming from ESA? And what do you think?
No, absolutely not. I think there's a lot of potential for commercial providers. So we can see it. There are a lot of new startups in the new space field with Earth observation satellites, with much smaller satellites, with really big constellations of satellites, so that we have a higher resolution in not just spatial resolution, also in time resolution. So the time resolution of Sentinel-2 data, for example, are 5 days. With the resolution by Planet Labs, for example, we have 1 day. And with ICEYE, we have maybe in the next years 1 hour tiny resolution. So that is there's a big impact, and mostly the commercial providers are a bit more flexible and innovative than the very big programs of the European Space Agency. Oh. But now we have the expert back. He can talk a bit more about this, I think.
Sorry for being out of the game for a short while.
No problem. So you will be invited next year when we have an event in probably in Munich. So internet connection won't be the problem. So we were discussing because I had a question because I mean ESA is publishing so much data for free and open data. If there is still a chance for commercial satellite providers to sell their data, or in, let's say, 10 years, ESA is conquering the whole market with their open space data. What do you think?
I think the main point here is the policy or the interest of the European Space Agency is to foster commercial and third-party mission data. And the logic of our satellites is to provide reference missions that are useful in order to cover large territories, and which can be complemented with other missions for very high resolution, for example, or for specific measurements. And the key idea is that we foster companies by buying data from them in order to complement the data sets that we are offering to the public, to the scientists, for example. We have 2 large programs, each endowed with several hundred million euros to buy data from ISI, for example. We are buying data from ISI. We are buying data from other commercial providers in Europe and outside of Europe. We have about 35 different missions that are giving us data, and we are buying it in a context of commercialization for companies to be used in the Copernicus context, for example. And we are doing it systematically also for the scientific domain. So we are buying data on a large scale to provide scientists for their specific science projects with data sets from commercial providers. So these are the 2 domains in which we are doing this. And that's the way that we try to support this. There's another program that we are running, which is helping. We are assessing the data of commercial providers with our quality standards, with our calibration tools, with our integrity tools, so that we can give commercial providers an assurance of the quality and the impact that the data can have in the commercial domain, in the scientific domain, and in the operational domain. So that's how we're trying to do this. And again, we are not trying to interfere or to block the business of these startup companies or even established commercial providers, because it's important to have a institutional reference. We call our satellites reference satellites. The reason why they are so expensive is they provide high-level calibration, high precision spectral bands, for example, that it's very difficult to obtain for commercial providers, at least for small commercial providers. And in that sense, we try to be complementary, and I think it's working quite well so far.
Thank you very much for elaborating on this. Unfortunately, we are running out of time, and also the next speakers for our panel discussion are already waiting. Nicolaus, you will join us in a few minutes again, but thank you nevertheless. Niklas, thank you very much for joining the whole session and answering so much questions. So let's see in about 9 minutes again. Thank you very much.
Thank you very much.
My presentation will be available, I understand. Huh?
Thank you.
I already told the audience, but thanks again for the remark.